Assalamu alaikum and welcome back to Civil Engineering 24/7 YouTube channel. This is Adnan Ahmed, and in today's video module, as we have seen yesterday, the procedure of calculating the strength of an angle, today we will solve a problem on the exemplar section. Okay, calculate the strength of an angle ISA 80 by 80 by 8 if is used as a strut. The length of the strut between interactions at each end is 3 meters. Assume ends to be welded. Okay, so generally you may be thinking what is a strut. Okay, let me define it here. Generally, uh, so strut is a support is a support used to retain the walls of vertical excavations. Okay, is known as strut. This what is defined strut? It may be a question in your semester about 4 marks. This definitions. Write this and draw a neat label diagram as it is showing in your video. CA like this. Okay, so generally let's move towards problem now. Okay, first of all, I said you always after seeing the problem write the given data. I will write the given data. So the given data in problem, it is given the ISA, Indian Standard Angle. Okay, 80 by 80 by 8 mm. So I will write it down here. ISA 80 by 8 E into 8 mm. Okay, and also it is given the length of the strut. Length of the strut, how much? 3 meters, right? 3 meters. Let me write down here. Finished? Now this was the given data. Now solution. Okay, let's write the solution. So first always write like this in your examination. From steel tables for ISA 80 by 80 by 8 mm. Okay, we need to go first from steel tables for ISA this section and just plot the areas. How much area is equal to? It is mentioned in your code book, 1211 mm square. Okay, then go for your RVV. Okay, RVV, that is 15.5 mm. It is also in your code book. Okay, so I will write it down here. This is your RVV. Okay, RVV. Now let us go for equivalent slenderness ratios. Okay, equivalent slenderness ratio. What is that mentioned in your code book? Lambda E is equal to under root of K1 plus K2 lambda VV square, okay, plus K3 lambda I square. Okay, this is completed. Now let's see the lambda VV. Okay, lambda VV. For lambda VV, again we are having the formula in your code books. Generally, let's go for the lambda. Okay, here lambda VV is equal to I divided by RVV. Again, epsilon under the root of pi square E divided by 250. Okay, now we have some I value, right? Moment of inertia. That is your 3 meters column mentioned in question. Just convert it into 3 into 10 power 3 divided by 15.5. Where the 15.5 we get? We get 15.5 from here, right? Or VV 15.5. Okay, 15.5. Okay, 15.55, 15.5. And then we have some Epson value. Always keep in your mind, or it is constant 1 into, again, under root of what is that, pi square into E value, that is modulus of steel, 2 into 10 power 5 constant, remember this value, again divided by 250, okay, into 2t. What is 2 into 2? And you don't know, you know t, that is into 8, okay, thickness. Now again let's move towards lambda phi. Okay, lambda phi is equal to b1 plus b2 divided by Epson under root of pi square e divided by 250, okay, into 2t. How much? Let me write it down here. Your breadth 1, breadth 2, okay, that is b1 plus b2 is given 80 plus 80 as section mentioned, okay, divided by again 1 under root. Why 1? Because Epson value is divided 1. Again we have pi square into 2 into 10 power 5 divided by 250 into 2 into 8, okay, so is equal to, the answer will come out after dividing this is your overall 0.112, okay. So after coming this value, next go for from, write again this sentence or this condition from table number 12 of IS 800 is to 2007, okay. This would be your first sentence in your while you're solving the problem from table number 12 of IS 800 2007 for the welded sections, okay. For just a minute, for the welded sections or welded ends or ends, okay, ends connected by more than by more than 2 boards and fixed end conditions and fixed end conditions, okay. You mentioned here. Now for the fixed end conditions, I have the values from the table number 12 as I mentioned before, 0.2 and K2 is 0.35 and K3 is 20, okay, K3 is 20. Now for lambda E, for the formulas, again we are going back for the formulas. In that 0.2 plus 0.35 K1 plus K2, I have mentioned in the older, let me show you that. Now I'm plotting this formula, I'm solving it here, okay. So what is that? Lambda plus 0.35 into 2.178 square, okay, plus 20 into 0.112 square, okay. After the 0.112 square, you get the root value is equal to 1.45. Lambda E is equal to 1.45. 1.45. If you solve this in your calculator, you get this lambda e value. Okay, now we go for the phi. Phi is equal to 0.5 1 plus alpha lambda e minus 0.2 plus lambda e square. Okay, from uh, from table number 10 IS 800 2007. What is I mentioned? Buckling class. Hang on guys, it is raining outside, so that's why it was in disturbance. Buckling class of angle section is class C. Clearly mentioned in your code book, this sentence, right? This sentence in examination. Okay, this formula, everything, just follow the procedure what I'm teaching here. Okay, for buckling class C, we find lambda is equal to 0.49 from your table number 10 for class C IS 800 2007 angle sections. Okay, now this thing is plotted. Again, 5 is equal to 0.5 of 1 plus alpha. Alpha is nothing but 0.49, 1.45 minus 0.42. Why 1.45 lambda e we already got here, right? That is I am plotting here. How much lambda e? Lambda e is equal to 1.45 minus 0.2 plus 1.45 square. Okay, we got the value 1.45 square is equal to, we come up for 5 value answer here. How much? Let me plot it down. 5 is equal to how much? I got 1.927. Okay, this is your 5 value completed. So 5 values completed, and now we are going towards now final steps for solving the problem. Let me write it down here. That is nothing but your design compressive strength FCD is equal to, what is the formula for FCD? FCD is equal to Fy divided by gamma m naught. Okay, FCD divided by gamma m naught, that is whole divided by again your phi plus phi square minus lambda square e divided by 1 by 2. Okay, so your Fy is always constant, that is 250 Newton per mm square. Okay, that is always constant. Keep remembering this value, 250 Newton per mm square. Now let us plot the or solve the formula. 250 divided by 1.1 Fy, we know Fy. Again lambda, what is lambda? Okay, let me write it down, the lambda value divided by 1.927. Again we are having 1.927 whole square minus lambda e square plus 1.45 square 1 by 2. Then I come out with the FCD value, that is nothing but the final values of the problem, that is nothing but 53.28 Newton per mm square. Okay, I got in some books it is 52.28 Newton per mm square, but in my calculator I got 53.28 Newton per mm square. None other than this answer is important, but the procedure which I am solving here is very important. Okay, next we see the finally axial load is equal to FCD into AE. What is that? 53.28 into your AE value, that is from your steel tables, cross sectional area 53. How much I got that time? I got the value of 1221. Remember? Okay, I got this value. So finally I got the answer of 64.96 kilo newtons. That is for PD. The solution completes here. Okay, the solution is completed here. If you like the video, Civil Engineering 24/7